Hey everyone, I'm Joshua Deemer, and welcome back to Lesson 12 of our Java programming tutorial series. Let's jump right into the lesson. So here I've made a class called player, and I've set it up with an ID, username, X, Y, health, and food. So just kind of a basic setup of a player. If I go to my main class and my main method, my static main method, I've created two different instances. Now, you'll notice that these instances can have their own data, right? It stores their own data and they're tracked by their variable names. Well, what if I want something that is consistent throughout all players? Well, I mean, technically I could add like an integer here, but what if I want to make it a little more organized than that? Well, I can go inside of the player class, and at the top I can say public. So let's say I say public int max health. Okay, so when they are regenerating or they heal themselves, I don't want them to go above 20. This is their maximum health. And what about food? So I want their maximum food to never go above 20. And we can make these final, since I don't want these to change. Okay, so now I can say something like player1.max health. However, this is something that should be the same for all players, right? I mean, you don't need to have it like that. You can always have it be like a RPG where your maximum health upgrades. But for my case, I want it to be 1 max health and 1 max food for every single player. That's what the static keyword is for. When I make it static like this, let's just go ahead and change this to max health and max food. I'll update the naming scheme to this. And so now you'll see, well, first of all, it's not that anymore, it's this. You'll see a yellow underline. If we hover over it, it says change access to static using player. There's no error, it'll run perfectly fine. However, if we click change access to static, it'll change it to the class name. That's because it's usable in all player instances. You don't need a variable created in order to get or set this maximum health. So if I want to up here to say player.max health, you'll also see max food. They're both right here. Okay, and I can do the same here. I could say player1.max food, but since it's static, I can just say player.max food. I can just use the class name. And the same goes with this static void main. If I say my class name, which is main, right? Main right here, dot main, I can actually call this method straight from my class. Of course, I wouldn't do that with the main method because then you would just cause a Stack Overflow exception, and we can go over that later. But this is a way that you can use static, using static to make it so that there's only one instance of the variable or method. So I added a static method here that says player report, okay? And it takes in a player and it's going to print out the username, the ID, the location of the players, X and Y, the health of the player over the max health, and the food of the player over the max food. So if I run this, it'll say the user, their ID, their location, their health, and their food. And the same with the other player, because I print it once, I add a blank line, and then I print it a second time. Okay, so this is fine. You can do things this way. However, a better way to do things is to use the player class that you make and make a class method. If I go ahead and I say public void report like this, and I take this code and place it in here, and if you look, we have all of the values here for the player. So I can just remove these, and it'll just grab the current player's information, except for these two, of course. But I can also remove player here since we're still inside of the player class. It knows what's up. So let's go over this really quick. If I were to remove this, and I go ahead and just not have anything, what this does is we create a instance or a class method. So this is not able to be something where you say report. Okay? It's not something where you can say player.report because it is instance dependent. So you need to rely on a player that you create. So if I say player1.report, now we see our method. And if I shift click or control click on it, it takes me straight to that method. And what it's going to do is it's going to use player 1's information in order to fill this out. If I made this into a static method, which I can, you'll see there are errors. And that's because it doesn't know which instance it's getting from, because the static keyword makes it so that you're using the player class rather than the player instance. If you use the player class, it doesn't know which player's information to get. And so you would need to define that more in here. As you can see, the static information is fine because those are based on the class rather than the instance. But I need to change this to be not static and instance dependent. Okay, so I change this to player1.report. If I change this to player2.report, or add player2.report, and in between I can say system.out.println and have quotes, you can see that this has a similar format as before. However, it's a more easy to look at, easier to understand, because we're going to this report and we're taking player 1's username, player 1's ID, player 1's X and Y. We're taking these variables in the same class inside of this method. And so now it's just a little more efficient. We can also do that with these. You notice that these have a similar pattern. And so we can say public void setup. And in here we can say string ID, string username, double X, double Y, int health, and int food. Okay, so that's cool. But now how do we set the current instance's information? Well, what we'll need to do is we'll need to say this.id is equal to ID. Since they're the same variable name, you need to define that we're taking this class's ID and setting it equal to the parameter's ID. You'll notice that these colors match up. So this is a lighter blue and this is a darker blue. That way you know which one is being used. If I say player ID here instead, I don't need to use the this keyword because it's a different variable name. Because if I just said ID equals ID, it's going to be like, what in the world are you talking about? Okay, so when we use the this keyword, that means that we are using this current instance. So this right now is a player because we are using this current player. Hopefully that makes sense. If it doesn't, I can do my best to explain it more in another video, okay? But for now, we can say this.username equals username. So we're taking this username, this player's username, and setting it equal to the parameter's username. Then we say this.x equals x, this.y equals y, this.health equals health, and this.food equals FOD, yes, food. Okay, these take the same principles that I told you in these two variables, okay? These four. So what we can do is instead of doing it all here, we can now say player1.setup, and you can see that there are 6, that's 6, right? Yeah, 6 parameters. So we can say A, B, C, D, E, F, G, and then in here I can say JD Computers, and then in here I say 0, 0, because that's X and Y. Then I can say the player.maxHealth, and the player.maxFood, because that's the health and that's the food. And if I take this away and we run it, you'll see that it prints it all out just like we made it. Let me comment out these two so we just do player 1. And let's change this to 10 and -10 and run it. Okay, so now we have 10 and -10. Alright, so let's break this down one more time, because I know that this can get confusing. If you know what's up, you can skip to the next section if you'd like. But we're taking this, and this is passed in as ID. Then the ID here is being set in the class's ID for us. And then we report that ID right here. And so you can see that it prints A, B, C, D, E, F, G. Okay, what about JD Computers? JD Computers gets passed in to username. Username gets copied over to the class's username. Remember, if we said username equals username, it's going to think we're using both of these. And so we have to say this.username. If we say this.username equals this.username, it'll think the same exact thing. Okay? You can, something also to consider, you can say this.report as well. It doesn't need to be just these variables for this specific purpose. If I wanted to, I could say this.username right here, and it'd be perfectly fine. But since there's no username variable already made in this method, I can just omit the this, and it'll assume that I'm talking about this. But if I said string username equals 55, I don't care, it'll now replace it with the one inside the method, and so I would need to say this.username, and now it'll use the class's username. So do keep that in mind. You can use the this keyword wherever you want, but just keep that in mind, okay? We do the same with the X, Y, and max health and max food. So like we pass in max food to our setup. It gets passed in right here. Here, then it's stored under this .food, which is right here, and then it's displayed right here. Cool. So that is how class methods work. So you might have seen that I made an ID here, right? And an ID here. Well, how do you automatically manage that? So some people, what they do is they have like int ID equals, or int ID, and then we have int current ID equals 0, and then you increment your ID by 1 and set ID equal to the current ID, and it continues like this so that it increments 1 by 1. So that the first ID is 1, the second ID is 2, the third ID is 3. It's called auto-incrementing. But what you can also do is a random string or a random unique unique ID. And so if I type UUID, and I'll just name it UUID, and set it equal to UUID dot random UUID, semicolon. So this is a static method underneath UUID, the UUID class. If I hold shift and click it, you can see all the information that Java provides us for with a class. Or, sorry, not shift, control and click. But this UUID is random. And so if I type UUID.toString, we'll get the string value of the UUID. So what I can do is, inside of here, I can say UUID.randomUUID toString. And so then it passes a string in. And I can do the same thing here. Random UUID to string. So it'll pass our random ID into the setup. And if I run it, you'll see that it generates a random string of unique identification. Now for the subject of the day, constructors. So constructors are similar to class methods, but they are called when you construct a new player. That's why they're called constructors. When you make a new instance of a player, it's run. That's why we see these parentheses here, because it's technically a method of sorts. And so if we go into player, the way to make a constructor is very similar to the way to make a method. You say your modifier, which is public. Then you can say so with a method, you would say something like public void constructor, right? Or public void setup, like we did here. However, to make a constructor, you need to match the name of the class. And you remove the return type. There is no return type for a constructor. So now we have our constructor. Now, if you want to be able to set certain things in your constructor, so for example, if we do string builder, come on, equals new string builder, you can see that this works fine. However, you can also add, say, a string inside of here, hello. But if I add a string inside of here, it throws an error, just like with normal methods. So if I go into my player here, I'm going to actually copy all of these and paste them in here. Then I'm going to copy all these and paste them in here. So this way, when we create the player, it'll create all the values alongside with it. If I go into here, you'll notice setup doesn't exist anymore, and there's an error here because we need to match our arguments to our parameters. So I'm going to copy this, paste it, copy this, and paste it. Then I can remove these setups. So the constructor allows us to set pretty much default values, run some methods, etc. Right? I could say report in here as well, and that would make it so I can get rid of these two, because once I create new players, it automatically reports for me. Okay? One other thing is these values are the same no matter what. So what I can actually do is I can remove these, go into player, remove this string ID, and I can say ID, since it knows we're talking about this ID now because there's no more ID parameter, ID is equal to uuid.randomuuid to string. So this will automatically create our ID for us without needing to put it in the parameters. And if we wanted to, we could remove these and just say that by default it's going to be max health and max food. That way, I can actually remove this if I wanted to and move these up so that they're kind of grouped a little better. It's personal preference. And so I can remove these and remove these. Now the code looks a lot cleaner, right? You can also store your UUID like this if you want and remove the toString. And so that way you can, inside of here, say something like player1.id.toString or compare to or whatever. You can do that outside of the player class so that it's not just a string. We've got a pretty solid class going on now, and in fact, if we wanted to, we could say things like public void move int x int y, and so we can say x plus, or this x plus equals x, and this y plus equals y. So we move the amount of x and the amount of y, and we can have plenty of methods. Public boolean is dead. Return if the health is less than or equal to 0. Or we can do all these sorts of things so that we can say if player1.is dead. And that's a boolean, so that fulfills a condition for an if statement, and we can do something with that, right? Or we can say player1.move, and you can say 5, 5. Okay, if I move this up and run it, you'll notice that he's now at 15, -5, because we added 5 to 10 and added 5 to -10. Okay, so you can do a lot of things with these class methods. But let's continue onward by talking about nested classes. So if we say public class, inner class, we'll just call it that. And outside of here, how do we create an inner class? Well, since this is a public class, we would say, and this will be a little confusing, player.innerClass. We'll say inner equals a new player, and we can just fill out our parameters or our arguments. .new inner class. That's how you create a inner class. Okay, it is a little confusing, but what's less confusing is a static inner class. If I add static to it, you'll see there's an error, but that's because all I need to do now is say a new player.inner class. Okay, what I'll be going over a little bit now is the usefulness of this inner class. Let's say you don't want people to flexibly create players. Usually you do and it's fine, but you can make this private, which means that I can't create it out here anymore. I can only create it if it's inside of this class. And so if I make a builder static class, I can say things such as private UUID or private string username, private int x, private int y, like this. And then I can say public builder. And inside of here, I'm not going to put anything. In fact, when you don't put anything, you can exclude the constructor. So I'm going to say public void set username to string username. Then I'm going to say this.username equals username. Down here I can say public void set x to int x. And I can say this.x equals x. And here I can say public void set y to int y. Then I can say this.x equals x. I can, whoops, not x. This.y equals y. If I really wanted to, I can just say set location. And I'll do x and y. This will save on a little bit of redundancy. And I can say public, and the return type can be a player. And I can build it. If I run this, I can then say return a new player with the username, x, and y. This will not return an error because we're within the class. And so we're able to build our player in this way. So let's take a look as how this would look inside of here. If I say new player, this won't work because our player constructor is private. But if I say player.builder, because I made a static class, I can then exclude these for now. And I can say .builder. Let's just have one so that it's less confusing. And so I'll call this builder. Then underneath I can say builder.set username to Joshua. Sure, that works. Then builder.set location to 1010. Then I can say player equals builder.build. Then I can say player.report. If I run this, you'll see that it runs perfectly fine, right? So let's take a look as to what this is doing. We're creating a new builder from that static class that I made, okay? Then we're setting the username of our builder to Joshua. So it's taking the username, putting it into here, and then this is setting this .username. So even though it's private, I was able to set it. However, I am not, if I say builder.username, I can't see it and I can't get it. I can only set it. Okay, so that's a benefit of that, and we'll go over more encapsulation later. Encapsulation is pretty important for programming. Then we can set a location with the X and Y with our set location here. We pass 10 and 10, so it sets X to 10 and Y to 10. Then we build it and create a new player. So when we build it here, it returns a player, and so now we have our player. This is called the builder pattern strategy. Okay, this is an actual strategy that a lot of programmers use. And there's a lot more strategies than just the builder strategy, but this is a common one that you may see. Then we can report the player, and it runs as intended. Because when we build, we pass our username that we set, our X that we set, and our Y that we set. And then those are all set here. And then these are already set for us. Since this is one of the most important aspects of object-oriented programming, I broke it down into two different parts. One is a little more intense than the other. So for part one, I want you to create two classes, one with the main method obviously, and the other for object-oriented purposes named car. Then I want you to put a minimum of 3 fields in for the car, and at least one static variable for the car, making it inaccessible outside of the car class. Then I want you to make the constructor for the car, taking in necessary parameters for your 3 fields that you make. Then I want you to make a report on the car using a class method. Once you are done with that, you can attempt part 2, which is more difficult. I want you to create one more class called animal, then create a UUID field for the animal. Okay, so a unique ID. Then I want you to fill out the animal with properties. For example, legs, tail, etc. And there needs to be a minimum of 3 more fields than just the UUID. Then you can use I want you to use the builder pattern strategy that you just learned to create an animal. So the hint that you have is to use a nested static class to build the animal. Then I want you to make it impossible to create an animal outside the animal class. Then I want you to create 2 different animal instances and use the builder pattern strategy that you created to make it inside the main method. Then create a minimum of 3 class methods inside the animal class. Okay, then run those methods once you create them inside of the main method. I'm gonna fade to black, but you can pause here if you'd like in order to do it yourself. Otherwise, we'll be going over it now. So I'm gonna move this over here so I can see it on my other monitor. Let's go ahead and create a new class. We'll call it main. I'll put it inside of the me.joshua.src package. Then I'm going to create the public static void main inside of it. Okay, we have our main class. Now let's go ahead and create another class called car. Hit finish. So inside of here, we need 1 static variable and 3 instance variables, so 4 fields in total. So here I'm going to say public string make, like I did before, public int miles, how many miles it has, then public float gas, how much gas the car has. Then up here I can say public static final. Then we'll say float max gas is equal to, we'll just say every single car in the world has a 12-gallon tank. Okay? But it also says make the car inaccessible outside of the car class. So that just means make it private. So now it is only used inside of the car class. Next up, we need to make the constructor take in the necessary parameters. So we're going to say public car, string make, int miles, and then a default for the gas. Otherwise, I can leave gas empty if I want. And so in here, I can say this.make equals make, this.miles equals miles, and then gas is equal to max gas. Then it says make a report on the car using a class method. So I can say public void report. Then we can say system.out.print line. We can say something like the make plus the make, and system.out.print line, the miles plus the miles, and then finally gas remaining is equal to gas plus max gas. Okay, so now that we've made the car, let's go ahead and create it. So we've got car, and then we'll call this Toyota equals new car. Now there's an error here because we take in a string and an integer. So we're going to call this Toyota, and it's going to be having 100,000 miles. If you want, you can format your integers or your numbers to have underscores in the middle. This is equal to saying just 100,000, but it makes it a little bit easier to understand for the human mind because we can say, okay, that's 100,000. We don't need to count the zeros and figure it all out from there. Okay, so you can do underscores. I'm going to keep the underscore. You can also say car RAM equals a new car, and then we have RAM, and it'll have 54321 miles. Then I can say Toyota.report and RAM.report. If I run this, it should say make Toyota 100,000, gas remaining 12 out of 12, make RAM miles 54321, gas remaining 12 out of 12. Cool, we've got our car running. So that's part one. Part two is a little more complicated, like I said, so let's go ahead and break this down piece by piece. We'll create a new class, call it animal. Then for the first field, it says to create a UUID, call it ID, sure. It needs to be imported because it's from java.util. Then we've got public, we'll say string name, the name of the animal if it has a name. Then public, or we could do string species if we want, sure. Public int legs, and then public boolean tail, whether or not it has a tail. Then we have our, it says, use the builder pattern strategy to create an animal. Okay, so what that means, and our hint is using a nested static class. So what we can do is say public static class builder. So this will build our animal for us. Then we can say private string species, private int legs, private boolean tail. This way the person can't get or set it unless if we specify that they can. And we could say public builder. But again, if you have a blank constructor like this and there's nothing inside it, then you can just omit it entirely. But you can also say things like tail equals true if you want by default. Then you don't want to leave this blank. The default for a Boolean is false though, and so if you want it to be false by default, then just leave it. You can say something like public void set species to a string of species. Then we say this.species equals species. You can say something like public void set legs to the amount of legs that you want. Then the nice thing about the flexibility of this is, since it's private, the person has to go through our set legs method. So we can say if legs is less than 0, then just return. We're not returning anything because it's a void, but this will cut the method short. Then we can also say, or legs is greater than 1,000. I don't know many species that have more than 1,000 legs. So we can say, if this or this is true, then just return and don't worry about the code down below. So down here now, we can say this.legs equals legs. Okay, then let's say public void toggle tail. We can say something like this if we want. Then we don't need to take in a parameter. We can simply say tail equals not tail. Okay, so it's going to set our tail equal to the inverted of what it currently is. So if it's true right now, it's going to set it to false. If it's false right now, it's going to set it to true. And it'll continue doing that every time you run toggle tail. Otherwise, of course, you can say set tail, boolean tail, and this.tail equals tail. Or you can say has tail. And then this would make tail equals true. Or you can say does not have tail and set tail equal to false this way. There are many different ways you can handle this. Okay? But then we can say public animal build. Then we say return new animal. Now this doesn't do anything right now because we need to do the next part. So it says make it impossible to create an animal outside the animal class. What that means is make it private animal, make a private constructor. So in here we're going to put the species, then the legs, then the tail. And so through this builder, we've actually already kind of set up a little bit of data validation. We're trying to make sure that the legs are a proper amount of legs, and you can do that with this. So inside of here, let's go ahead and say id equals uuid.random uuid. So now we have a random ID. This.species equals species. This.legs equals legs. And this.tail equals tail. So now we set that all up. So let's put it inside our constructor here, or our instance here. So species, legs, and tail. Okay, we've created the class. Now it says create two different animals with the builder inside of the main method. So I can say animal, we can say animal.builder. Builder equals a new animal.builder. Okay, nothing wrong here. So if we say builder.set, we've got a lot of it. We've got a lot of different options because we added a lot of different options. We got like toggle tail, we've got set tail, set species, set legs, has tail, all these different things. Does not have tail. So let's just do set species. We'll do dog. And builder.set legs to 4 because a dog has 4 legs usually. And then set tail, it does have a tail. Or we could say has tail. Right? So we can do either or. I'll just do set tail since that makes a little more sense. And then we'll say animal dog is equal to builder.build. So now it builds the animal for us. We'll just call this builder1 for now. This isn't technically proper naming, but that's okay for now. And you'll notice if I say animal cat is equal to a new animal, there's an error because animal is not, first of all, we need to fill those out, but animal is not visible because we made it private. So that's good. Now we'll say animal.builder because it wants two of them. Builder2 is equal to a new animal.builder. And we'll say builder2.setSpecies to cat. Builder2.setLegs to 4. And builder2.setTail to true. Okay. I'm going to move this down here, and I'm going to move this up here to make it a little bit more organized. Just my preferred style. Animal cat is equal to builder2.build. So now we've got two animals built through builders. Again, you don't need to use builders. This is just a more advanced form of object-oriented programming. It uses patterns to make these instances. So now we need a minimum of 3 class methods. Okay? So let's say public void. What could be the first one? Well, what we could do is we could say public int x, public int y, public int tail position, like this, and we could say wag tail. Then what we could do is we could say tail position plus plus. We can do something real basic like that. We could say public void move int x, int y, and this dot x plus equals x, this dot y plus equals y. Or we could do public void teleport int x, int y. This dot x equals x, this dot y equals y. There is a difference between moving and teleporting. The plus equals versus the equals. Okay, so you'll notice that I never really initialize them fully, these 3 variables. That's because they'll be set to their defaults, which for integers is 0. If we left this one alone, the default would be null. Same with the string, the default would be null. So now let's go ahead and do dog.move. Wow, I don't know how that popped up. Dog.teleport to 5, 5. And what was the other one? Wag tail. Yay, we move, teleport, and wag tail. Cat.move -1 -500. Then cat.move to 10, 50. And, not move, teleport. Then cat.wagtail. Okay, we went ahead and did every single part of part 1 and 2 of our task. Now, understanding the builder pattern strategy isn't too important, but it is important for you guys to know how class methods, constructors, and fields work before continuing on. So make sure you have a firm understanding of those 3 things before continuing, okay? That's the end of this episode. Next episode, we will be covering comments and naming in Java. Thanks for watching. Feel free to comment what your thoughts are on the series so far down below. Don't forget to like, subscribe, and ring the bell so you don't miss a video. Bye!